Hi and welcome. I hope everyone is okay. Now, in this lesson, I hope in the last lesson in the video series, because I'm going to Germany on Monday, and maybe we will meet face to face on Monday. But I want to make a video about Monday's lesson, because we will only meet on Monday. But I want to learn, and I want you to go on your statistics lesson. Our lesson, we will pass chapter 4 about probability. However, as you remember, you had learned something probability about probability in the previous years. But in this year, in statistics lesson, you will learn different things about probability, and very large your topic. Your topic is very large. It will be large, and now we can start the probability. In this lesson, something I remember to you about probability. Okay, now probability measures the likelihood of an event occurring on a scale from 0, it's called impossible, to 1, it's called certain. We write this as P, name of event, and its value can be expressed as a fraction and decimal or percentage. The greater the probability, the more likely the event is to occur. Although we don't often calculate probabilities in our daily lives, we frequently assess and compare them, and this affects our behavior. For example, insurance is based on risk, which in turn is based on the probability of certain events occurring. Government spending is largely determined by the probable benefits it will bring to society. And experiments, events, and outcomes are experiments, events, and outcomes. The result of an experiment is called an outcome or elementary event, and a combination of these is known simply as an event. For example, rolling an ordinary fair die is an experiment that has 6 possible outcomes: 1, 2, 3, 4, 5, and 6. The fairy die has these outcomes. Obtaining an odd number with the die is an event that has 3 favorable outcomes: 1, and 3, and 5. The number of experiments, it shows us like this, and the number of experiments, 6 possible outcomes, 6, and our event is, for example, the number of events, odd number, 3. And the tossing a fair coin is an experiment that has 2 possible outcomes: head or tail. So the number of experiments is 2, and obtaining a tail with a toss is an event that has 1 favorable outcome and tail. So this event, number of events 1. Okay, and selecting randomly one student from a group of 5 girls and 4 boys is an experiment has 9 possible outcomes. So the number of experiment is 9, and the obtaining a girl with the selection randomly is an event that has one favorable outcome. So this event is a girl, obtaining a girl with the selection randomly event. So the number of selection randomly a girl, for example, is key, and we have 5 girls, so the number of girls if all selection is 6. Okay, and random selection and a queue probable events. The purpose of selecting objects at random is to ensure that each has the same chance of being selected. This method of selection is called fair or unbiased, and the selection of any particle object is said to be equally likely or equiprobable. When one object is randomly selected from n objects and the P is selecting any particle object 1 over n. The probability that event occur is equal to proportion of equally likely outcomes that are favorable to the event. The probability of events equals to number of favorable as equally likely outcomes, and as you remember in the examples, SE over total number of equally likely outcomes, the number of experiments. Okay, and this formula gives us the probability of event. The probability of event, for example, our event is called A, and the probability of A means the number of A over the numbers of experiments. Okay, and consider randomly selecting one student from a group of 19 where 11 are boys and 8 are girls. So we have 19 students and 11 are boys and 8 are girls. There are 19 possible outcomes, so the number of experiments is 19. 11 are favorable to the event selecting a boy, so the number of boy selection or selecting is 11, and 8 are favorable to the event selecting a girl, so the number of girl is 8, as shown in the following table. But I want you to notice notice a word. The word is particle. Particle means specifies one object, a specific object. If you read like a particle, it means a specific object or specifies one object. So it doesn't matter whether that object is a boy, a girl, or student. Each has 1 over 19 chance of being selected. Please notice that selecting selecting any particle boys, one boy, any particle boy, one boy. So the probability of any particle boy is 1 over 19 because one object. Selecting any particle girl, so the probability of particle girl 1 over 19. Selecting any particle student 1 over 19 because this is it means one object, one student. Particle word is very important in the probability questions. But if they tell us selecting a boy, any boy, we have 11 boy. So selecting the probability of selecting a boy 11 over 19. And selecting a girl, any girl, so we have 88 girls. So the probability of selecting a girls 80 over 19. So if you see the particle word means specific object, specified one object. But if you don't see the if you don't see the particle word, that it means any boy. So we have 11 boy, so we selection the 11 boy. Okay, it's very important that they are difference, you know and you understand that they are differences. Okay, and excuse me that okay, my alarm, morning alarm. Yeah, and exhaustive events, a set of events that contains all the possible outcomes of an experiment is said to be exhaustive. In the special case of event A, its complement not A. Not A showed like a complement, its A complement, and not E showed these like this. The sum of their probabilities is 1 because one of them is certain occur. So the probability of A plus the probability of the complement of A, should be 1. Okay, and recall the notation. Yes, this notation. Recall the notation used for the complement of set A is A. This proportion. Examples of complementary exhaustive events are shown the following table. For example, toss a fair coin. The probability of heads, 1 over 2, and the probability of the complement of the A, it means tails, so 1 over 2, and 1 over 2 are plus 1 over 2, 1. Roll a fair die, so less than 2. Less than 2 means, only 1. So the probability of A, 1 over 6. And the complement of A means 2 and 3, 4, 5, 6. So we have 5 objects. So the complement of A, the probability of the complement of A means 5 over 6. And the probability of A plus the probability of the complement of A means 1. Play a game of chess, win or not win. So or lose. So probability of win plus the probability of lose means 1. Okay, so I want to write again the probability of A plus the probability of the complement of A means 1, also 1. For example, you have a box and you have five yellow table, five yellow ball, and for example, six red balls. And you want to choose a ball, and the probability of yellow ball 5 over 11, the probability of a red ball 6 over 11, and also the probability of a red ball means the probability of the complement of yellow, the complement of yellow. So the probability of yellow ball plus the probability of red ball means 5 over 11 plus 6 over 11 means 11 over 11 means 1. So you know, choosing a red ball means the complement of yellow, okay. Now thrills and expectation. Each repeat of an experiment is called thrill. The proportion of thrills in which an event occurs its relative frequency, and we can use these as an estimate of the or the probability that event occurs. If we know the probability of an event occurring, we can estimate the number of times it's likely to occur is a series of thrills. This is statement of our expectation. For example, you in an thrills event A is expected to occur and multiply the probability of A, and for example, you toss a coin, uh, 60 times. You toss the coin, fair coin, 60 times, and the probability, the probability of a hat is 1 over 2, and in the 60 times you expect the number of hat, the probability and multiply the probability of hats. So 60 multiply 1 over 2, so you expect that 30 times 30 times obtaining hat, okay, because you toss the coin 60 times and you expect that 30 times take the result of hats, okay. And a worked example. The probability of rain on any particular day in a mountain village is 0.4. The probability of rain on any particular day is 0.4. On how many days is rain not expected in a year of 365 days? So not expected. The probability of rain 0.4. So the probability of the complement of rain or not rain means 1 minus 0.4 means 0.6. And in a year of 365 days, you expect not rain. You expect not rain, and multiply the probability of the complement of rain. So 365 multiply 0.6, and I want to use my calculate. 365 multiply 0.6 means 219. So you expect that 219 days not rain, okay? Or you not expected rain in a year, or 219 days, okay? And we have other question worked, and we will solve this question. United's manager estimates that the team has 65% chance of winning any particular game, and 85% chance of not drawing any particular game. And what are the manager's estimates most likely to be based on? Also, the United's manager estimate looking at the previous matches, matches. Okay, what are the manager's estimates most likely to be based on? Based on they ask us previous match, looking at the previous match. And if the team plays 40 games this season, find the manager's expectation of the number of games the team will lose. The probability of win. The probability of win 65%, and the probability of not drawing the complement of draw, 85%. So the probability of draw is 100% minus 85%. So the probability of draw means 15%. Okay, and a team is likely situations win or draw or lose, and the sum of all situations probability is should be 1. The probability of win plus the probability of draw plus the probability of lose should be 1. The probability of win 65%. The probability of draw means 15%. Plus the probability of lose means equals to also 1. And the probability of lose means 1 minus 80%. So the probability of lose means 20% or 20 over 100 or 0.2. Okay, and the manager, if the team plays 40 games this season, find the manager expectation of the number of games the team will lose. So the team 40 times have the team has 40 times match, and the manager expectation 40 multiply 0.2 and 8 matches his team or her team lose. Okay, and the last one, if the team loses on one game more than the manager expects this season, explain why this doesn't not necessarily mean they performed below expectation. Maybe the team one game more than a manager expects this season, but please remember that the probability of the complement of draw is 85%. So maybe the team win the game that manager expects the team draw. So maybe a match the manager expects draw, the team's draw, but maybe the team win these match. Also manager expects this match result draw, okay, but maybe it might be draw his team. So we don't necessarily mean they perform below expectation. Maybe in a match team win, okay, team might win. And we have the last question about introduction of probability. And a numbered hill like this is divided into 8 sectors, these equal size, okay, as shown. The hill is spun until it stops with the arrow pointing at the numbers, okay. Axel decides to spin the hill 400 times. Find the number of times the arrow is not expected to point at 4. Find the number of times the arrow is not expected to point at 4. Okay, now we have 8 equal size section. So the number of experiments is 8, and we have 1, 2. We have 2 sectors is written 4. So the number of event, for example 4, means 2, because we have 2 sectors on is written 4. So the probability of obtaining the 4 means 2 over 8 means 1 over 4. The probability of not obtaining the 4, it's the other way, the other we say the complement of 4 means 1 minus 1 over 4. It means 3 over 4. And find the number of times the arrow is not expected to point at 4. Not expected to point at 4 means and multiply the probability of the complement of 4 and 40 times multiply 3 over 4, and it means 300. How many more times must Excel spin the wheel so that the expected number of times that the arrow points at a 4 at least 160. So n times the number of times, let it be n, and multiply the probability of 4 should be 160, and multiply 1 over 4 should be 160, and our result is we carry out the 4 as a factor, this here, and multiply 4 and equals to 4 multiply 160 means 640 times. Axis, if 640 times spin the wheel, maybe Excel expects at least 160 times obtaining C4 sector. Okay, now our lesson, in this lesson we learned the probability and expectation. For now our lesson finish, and have a good days and have a good weekdays.